Now for the ever important topic, rate of change and slope. Let's look at some problems with this. So rate of change, it is important to know that your rate of change is always your change in y divided by your change in x. So if we look at a table like this, okay, for this data in this table, I want to know is the rate of change for each pair of consecutive mileage amounts the same, and if so, what is the rate of change? So if you're looking at this and you're trying to figure out y and x, because the miles is the independent variable, it's x, and the phi is your y. And I want to look and I want to see if the rate of change is the same. It looks like the y is going up by 12 is the difference here, while the x goes up by 50. Here the y goes up by 12 again, and the x also goes up by 50. And here again, it goes up by 12 when the x goes up by 50. So it looks like every single time the rate of change in y is 12 and the change in x is 50. Every time that is the same. And 12 divided by 50 is 0.24. If I am calling this a rate, then I need to label it with my rate if I know the units. And here it's dollars per mile. So it looks like $0.24 per mile, or 24 cents per mile is the fee for the miles driven, and is the same every single time. All right, if we're looking at a graph and I want to figure out the rate of change, you really do the same thing, but we might have a little bit different vocabulary for it. So rate of change is called the vertical change over the horizontal change. So again, it's change in y over change in x. In this cool triangle, it's a Greek letter delta, and it just means change. So this is the change in y over the change in x. So same thing a lot of times, and I'll write this later again, but we look at that as rise over run. How much the vertical change, how much your graph rises, and the horizontal change, how much it runs, how much it goes over. So let's look at this graph. This is a distance traveled by a motorcycle from its starting point. If I was going to ask you to find the rate of change, I would try to find some nice dots that I can work with on the graph. And it looks like a couple are already highlighted for me down here and in the middle of the graph. So I'm going to kind of make a little triangle here and figure out the rate of the rise, how much the vertical change was, and the run, how much the horizontal change was. And it looks like it goes up from 0 to 400. In that case, it's going up 400. And it's going over 20. So my rate of change would be 400 over 20. Okay, that equals 20. But I need to explain what this rate of change means. So 20 is like my vertical distance over, if I reduce that 20 over 1 second. So it looks like I'm going 20 meters, I think that's what that is, per second. 20 meters per second is what that means. That motorcycle goes 20 meters every second. All right, slope. Slope is another word that means rate, but slope is like the really official word that you'll hear a lot when we're really dealing with this math. Slope is rate. So slope, the slope of a line is the same thing as its rate of change, and slope, you often hear it described as rise over run, like I talked about on the last page, or again, change in y over change in x. So it's not different, it's the same thing that we're dealing with rate. I would like you to find the slope of each line. Okay, try to do this without me, and then come back and see if you get it right. Okay, so again, if I'm looking at a line, I want to find any two good points on the line, and I'm going to find the rise over the run. So it looks like here, if I make this little triangle like they did, it's going from 4 to 1, it's going down 3. I like to think of that as negative 3. And it goes from 0 to 2, it goes right 2. So the slope, the rise over run, is negative 3/2. And a lot of times you'll leave it as a fraction there. You may also write it as negative 1.5. Both would be correct for that slope. Okay, for this one on the right, again, I could pick different points than they pick. I could pick from here to here if I wanted, but I want to show you that we're getting the same thing. So from here to here, I'm going up 4 and over 2. If I did 4 divided by 2, I get 2. If I picked a different place like the ones that they picked, looks like I go up 2 and over 1, but still 2 divided by 1, it equals 2. And it's going up left to right. This is a positive rate of change. Okay, the slope is positive. It's going up from left to right. This has a negative slope. It's going down from left to right. So make sure you're keeping that in mind when you're figuring out if your rate is positive or negative. All right. What would you do? want to see if you can try to do this without me guiding you all the way through it. Really do try. Without graphing, how could you figure out the slope of the line through 2, 3 and 5, 7? Okay, so it's going from the point 2, 3 to the point 5, 7. Try to do that before I give it away. Okay, remember that slope is rise over run, also known as change in y over change in x. Okay, I'm going to give you one method that I usually use to do this, and then I'll show you another official method. So I usually look, okay, 2, 3 to 5, 7. Well, 3 and 7, those are my y's. So look, like, how much did it rise? What was the change in y? It went from 3 to 7, it went up 4. Okay, and then I look at my run, my x is my change in x. It went from 2 to 5, it went up 3, so that's a positive 3. So 4/3, that's my slope. Okay, so if you're finding, what would you do to find the vertical change? That's always the change in y, and the horizontal change is the change in x. One thing that you can do is subtract your y values and your x values. Here's my official formula. Slope is the rise over run. What you can do is subtract y sub 2 minus y sub 1 for the rise, and then divide that by x sub 2 minus x sub 1 for the x's. So for example, again, if I go from 2, 3 to 5, 7, most of you know that these are x and y, x then y. In my first ordered pair, these we just put the x sub 1, y sub 1. The second ordered pair, x sub 2, y sub 2. So when I'm doing this, I'm taking y sub 2 minus y sub 1 on the top. So I'm doing 7 minus 3 on the top. Lo and behold, when I do that, it gives me 4, which is what I found out earlier when I was going to rise. And x sub 2 minus x sub 1, so I'm doing 5 minus 2, which equals 3. Lo and behold, that's what I got above before when I figured out the run. So here's my official formula for slope. It's important to know it's change in y over change in x, and you can do it in many ways, but you should arrive at the same answer, and this should also tell you whether it's going up or down. Okay, let's look at some more examples. So find the slope of each line through E, which is 3, negative 2, and F, which is negative 2, negative 1. So I'm going to show this in both ways. Okay, so I can either use this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or I can just simply look for the change in y over the change in x. And I hope I get the same answer both ways, but let's check. So change in y, it goes from negative 2 to negative 1, so that looks like it's going up 1 space. Okay, from negative 2 to negative 1, it's rising up 1. And then the change in x is going from 3 to negative 2, so it starts at 3 and goes all the way down to negative 2, it goes down 5. So I think 1 over negative 5 or negative 1/5, that should be my slope. Okay, I'm going to try it with my slope formula and see if I get the same answer. So again, my y sub 2, second y is negative 1, minus my first y, which is negative 2, over my second x, x sub 2, negative 2, minus my first x, which is 3. So negative 1 minus negative 2, remember that's the same thing as negative 1 plus 2, that's 1. Negative 2 minus 3, that's negative 5. It is the same thing as I got. Negative 1/5 is my correct answer. Okay, please try these two and see if you can come up with it. Okay. All right, so A. If I look at something like this, it goes from negative 4, 2 to 1, 2. And I'm looking for my slope and I'm looking at my formula. So remember, I'm going to do change in y over change in x. It looks like my y, to go from 2 to 2, it did not change at all, and 2 minus 2 is 0. For my change in x, it went from negative 4 to positive 1, so it changed by 5. If you try 0 divided by 5, you get an answer of 0. We say the slope of this horizontal line equals 0. Okay. Looking at the second one, it's a little trickier. Again, if I do change in y over change in x, it looks like my change in y, the y values, it goes from negative 4 to 1. So it looks like in this case it changed by 5. In my x, it looks like it went from 2 to 2, so it did not change at all. So 5 over 0. What happens when you try to divide by 0? like you have 5 things, you're trying to put them into 0 groups. What's happening? Try it on your calculator, something. Whatever you're going to do, you're going to see that there is an error here. You can't divide a number by 0. So because there's an error, we say that something like this is undefined. Okay? We can't divide by 0. This gives me an undefined answer. It's not a number I actually have that exists. So this is true with every horizontal and vertical line. For a horizontal line, the slope is always going to be 0 because the rise is 0, and when you have 0 divided by a number, it always equals 0. And remember, horizontal goes like this way. And the slope of a vertical line that's undefined, it looks like this. Okay, I've tried to tell you why that happens. Okay, remember it has to do with dividing by 0, but I want you to see if you can kind of formulate a really good answer to this question that you'll be able to share with me and or the class. Okay, a couple other things I want you to know about. If a line slants up from left to right, so you look at it, it goes up from left to right, what do you know it's about its slope? Okay, what if a line slants down left to right? Okay, try to answer those 2 questions. Pause the video, see if you can come up with something. Okay. What I'm hoping you came up with is that it goes up from left to right, it has a positive slope. If it goes down from left to right, it has a negative slope. These are really important that you can just look at a graph and know if the slope is going to be positive, negative, 0, or undefined. I want it to be like really obvious and just really quick at it. All right, let's close this up. Things to ponder. Okay, so we learned many formulas for slope today. Tell your partner. I know I always have these partner words in here. So that, again, that can be anyone you want it to be. As many of them as you can remember. The more that you know, the better off you are. Okay, and do all those formulas mean the same thing? And then lastly, what is slope? What does that really mean? What does it really tell you? Okay, these would be good things for you to write down, think about, talk to me in class, earn that chip. Have a lovely afternoon, evening, morning, whenever you're watching this.